Number 4, a tiger leaps with an initial velocity of 55 kilometers per hour at an angle of 13 degrees with respect to the horizontal. What are the components of the tiger's velocity? So components, okay, so I'm going to need to break that up into x and y. So what do I have here? I have, it's a velocity, right? So I have a velocity of 55.0 kilometers per hour. And my angle was, where is it? 13 degrees above horizontal. So again, here's my triangle. $55 per hour. My angle is right here. And I need the x component of the velocity and the y component of the velocity. So in one instance, I'm going to use the cosine. The other, I'm going to use the sine of the angle. So the y component of the velocity is going to be the velocity, which is the hypotenuse, y component over here, that's opposite the angle, so it's going to be sine. And then the horizontal component is again going to be the original velocity, because that's the hypotenuse, multiplied by the cosine of the angle, because the x component of the velocity is the adjacent side to the angle that we're looking at. So when I actually plug this stuff in, kilometers per hour multiplied by the sine of 13, and then I would have 55 kilometers per hour multiplied by the cosine of 13. You guys notice how the setup for each of these calculations are almost identical? The only difference is using sine or cosine. Right? That's how simple this gets. And so when I plug this into my calculator, I come up with 12.4 kilometers per hour. And we'll call that and for the x component, when I put that in my calculator, I get 53.6 kilometers per hour, and we'll call that forward.